You've probably come across the concept of a percentage many times, and often this is like the percent score that you get on a test or something similar, and you know that closer to 100% is closer to the ideal amount, and closer to 0 is, well, closer to the less desired amount. But what do we really mean by percent? And for chemists and other scientists and engineers and other professionals in technical fields, how can we use a percentage as a conversion factor? So, percentage is defined as the number of items of a given type in a total of 100 items. And we'll often calculate it by taking the number of items of interest, dividing that by the total number of items, and then multiplying by 100. And you've probably done that to calculate the percentage of a test score, right? You get the number of correct points, which is your number of items of interest, divide that by the total number of questions or the total number of points, and times it by 100. But there's another way of thinking about percentage, which is that it is the number of items of a given type in a total of 100 items. So we can think of it as being the percent as being number of items that we're interested in for every 100 total items. And in this form is how we tend to use percentage as a conversion factor. So we'll keep that in mind as we move through. So percentage can be used as a conversion factor. So here's an example. It says an alloy was found to be 66% zinc by mass. And that allows us to write a couple of conversion factors, because what this really means is that we get 66 grams of zinc for every 100 grams of alloy. Now it just says by mass, so you could make that pounds or you could make that kilograms or whatever, it wouldn't matter, as long as they were in that ratio of 66 to 100. Or the other way of saying this is that you could you could say that for every 100 grams of alloy, 66 grams of it are zinc. And the conversion factor that you would write would just depend on the conversion that you were wanting to do. As I said, you can use any units for the mass here as long as they are the same in both the top and the bottom of your conversion factor. So it's a pretty useful idea. So here we go. It says a sample of air is found to be 20.9% oxygen by volume. How many milliliters of oxygen are present in 375 milliliters of air? So I'm going to use dimensional analysis. I've got 375 milliliters of air and I want to turn it into milliliters of oxygen. So I know that I'm going to have to multiply by something that has milliliters of air on the bottom in my first conversion factor, right? And that's what I do here, because I'm going to use this percentage, which is really saying that I get 20.9 milliliters of oxygen for every 100 milliliters of air. And so there it goes, right? So when I do this, I know that not all of my air is oxygen, so my number should be, smaller than 375 mils. So I know I've set the math up correctly because I've done the dimensional analysis. And then finally, here we go. So that's going to leave me with oxygen. Finally, I'm just going to put the numbers into my calculator, do the math, and I get a number that is smaller than 375. So I feel happy. All right. Another use of percentage that you'll see in chemistry is to calculate the percent error of a measurement. And to do that, you're going to use the following formula. So the error is just the difference between your measured value and the value that is accepted as being correct. So this is your error part. And then we're going to express that as a percentage of the accepted value, and then we're going to times that by 100 in order to do that. So it's the measured value minus the accepted value. That has to be in parentheses, don't forget that, divided by the accepted value times by 100. And it can be either a positive number if your number is too big, or if your number was measured to be too small, it will be a negative number. So here we go. It says the length of a piece of string is known to be 30.2 centimeters. So what this means for us is that that's our accepted value. A student measured this string to have a length of 29 centimeters. So that's our measured value. And then it says, what is the percent error of the measurement? Well, our measured value is less than our accepted value. So I know it's going to be negative for a start. So now we're just going to put it into the formula, and we hopefully are going to get a negative number. So it is measured value minus accepted value divided by accepted value times 100. And sure enough, I got a negative value, which is consistent. All right, so let's have a look what the types of problems in ALEKS are going to be like. So it says a chemist mixes 9.2 grams of water and 96 grams of methanol and 89 grams of butanoic acid. So methanol is the kind of alcohol that doesn't get you drunk, it kills you, but first it sends you blind and gives you a horrible stomach ache. And then butanoic acid is the acid that's produced by bacteria in the case of stinky feet. So butanoic acid is stinky feet. So we've basically got like stinky death juice here. All right. So it says calculate the percent by mass of each component of the total. So what we're going to need is to calculate the total number of parts. So I'm going to do 92 plus 96 plus 89, and that's going to give me the total grams. So now we're just going to add these guys together. 92 plus 96 plus 89. Boom. 277 grams. 277 grams, and that's my total. So when it comes time to calculating the percentages here, I know that the biggest percentage is going to be the methanol, the smallest percentage is going to be the butanoic acid, and the middle percentage is going to be the water. So I want to keep that in mind. So let's just go through and do it. So percent water is going to be 92 over my total 277 times 100, and it's going to be less than 100, right? And then I'm going to do percent the methanol, and just making sure I don't make an error. 96 on 277 times 100, and then finally percent butanoic acid is going to be 89 on 227 times 100. And if I add those three percentages together, they should add up to 100. So that's worth keeping in mind. So let's just do those now. Move my calculator over. So I got 92 on 277 times 100. There we go. So I want this to two significant figures, so that's going to be 33% for that guy. And then I know that my methanol, when I come to do that, it's going to be a bit bigger because I've got more of the methanol. So the methanol is going to be 96 on 277. Don't forget to do your times 100, really common to forget that. And then that's going to be 35 to two significant figures. And then finally, got my butanoic acid, which was 89 on 277 times 100. There we go. And then to two sig figs, that's going to be 32. So if I add all of those together, 33, 35 plus 32, they should be very close to 100. We did round a little bit, so it might not be quite precise. So 32 plus 35 plus 33. Bingo, 100. So we know we got it right. And then we're just going to check. The biggest one should be the methanol, which it is. The next biggest one should be the water, which it is, and the smallest should be the butanoic acid, which is the case. So pretty convinced that we got it right. Okay, so that just concludes that little section on using percentage as a conversion factor and calculating the percentage components of different mixtures. Hope you found the video helpful. Good luck with everything.